Have you, at any point, examined whether we're genuinely alone in the universe? Or are you accepting that there's something more to our existence than what we see? Imagine what would happen if the James Webb Telescope finally shows that we live inside a black hole. It could change everything as we learn more about this groundbreaking discovery, which will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a terrifying dream. Sure, you might have seen them in sci-fi movies, but in reality, they're truly frightening. According to scientists, black holes in space are believed to contain enormous amounts of matter compressed into an incredibly small region. Imagine a star, typically much larger than the Sun, packed into a sphere the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for a long time. They have studied objects in space that are so massive and dense that they can trap light. The most famous theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star collapses, it leaves behind a dense core. If the mass of this core is several times that of the Sun, gravity takes over completely, leading to the formation of a black hole. Detecting black holes is no simple task since they do not emit light. However, researchers have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole moves through a cloud of interstellar matter, it will pull that matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be torn apart, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful radiation, and even influence the formation of new stars, sometimes accelerating it and sometimes slowing it down. But where do black holes come from? Imagine stars, once enormous and powerful, meeting their violent end in a spectacular event known as a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life cycle in a supernova explosion. Smaller stars, when they die, become what we call neutron stars, extremely dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these collapses occur, something strange happens near their surfaces. Time itself begins to behave differently. From the perspective of a distant observer, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to our own. Sometimes, when two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, they create a massive cosmic phenomenon that defies understanding. Scientists have been trying to comprehend the scale of these gigantic mysteries for decades. Black holes come in two primary sizes, large and small. However, small is a relative term when it comes to black holes. Stellar mass black holes, the remnants of giant stars, can be anywhere from 10 to 100 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. But wait, there's something even more colossal. Supermassive black holes exist at the far end of the spectrum. These behemoths are millions, if not billions, of times larger than the Sun. They reside at the centers of massive galaxies, including our own Milky Way. It's like a monstrous dead space pulling everything toward it. The renowned physicist Stephen Hawking studied black holes extensively throughout his life. His discussions were always fascinating, yet some of his theories couldn't be confirmed due to a lack of necessary equipment. But there's hope on the horizon. A single scientific instrument is making a massive difference: the James Webb Space Telescope, JWST. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human ingenuity. Sure, we've launched other space telescopes before, and they've done their jobs well, but this powerhouse is truly extraordinary. The JWST makes the Hubble Space Telescope, which has served us for decades, seem like a mere speck in the vastness of the universe. And the price tag for this astronomical wonder? A staggering $10 billion. Yes, you heard that right. That's enough zeros to take your breath away. This miracle of science was brought to life through the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, with invaluable contributions from over 300 universities. However, Such an ambitious project comes with significant risks. The JWST is venturing into uncharted territory, pushing the limits of what we know and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its initial mission lifespan. Since its launch, the JWST has accomplished some incredible feats. It traveled over 1 million miles to reach its orbit around the Sun, where it will remain permanently. During its journey, the telescope successfully deployed its massive 5-layer sun shield and giant primary mirror, both of which had to be folded to fit inside the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is nearly ready for full operation. One of the most breathtaking moments of the JWST mission was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots from the star's light captured by the 18 mirror segments of the primary mirror. Later, NASA released another stunning image of HD 8446, in which the 18 unfocused copies of the star were arranged into a deliberate hexagonal pattern. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the process of image stacking, combining the 18 images into one clear view. Thanks to its state-of-the-art technology, the JWST will help scientists study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed in a period known as the epoch of reionization, when neutral hydrogen was reionized, gaining an electric charge again due to radiation from these first stars. This involves looking back billions of years, something only a powerful telescope like the JWST can achieve. The telescope will also aid in discovering exoplanets, which are incredibly difficult to detect due to their interaction with their host stars. Its powerful sensors will be able to observe these planets in greater detail, sometimes even imaging their atmospheres. Understanding the conditions of these planets could help scientists determine whether certain planets are habitable. As we continue to explore the farthest reaches of space, the mysteries of black holes will continue to captivate our imaginations and drive scientific discovery.